All right, so now we're moving on from adding and subtracting polynomials to multiplying polynomials. The first thing we're going to start with is simply multiplying monomials, which means multiplying one term by one term. And what I want to show you is that the bracket here means multiply. So we're doing 8k cubed y times 9ky cubed. But I could also just write this as a giant multiplication, meaning I could write it as 8 times k cubed times y times 9 times k times y cubed. And you don't have to do this every time. But I find sometimes it's nice to see this the first time to make you realize that it is just a big giant multiplication of variables and numbers. So that then I could say, well, I'm going to multiply the 8 and the 9 together. I'm going to multiply the k cubed and the k together. And I'm going to multiply the y and the y cubed. And I stopped writing dots because you don't really need them, but they're kind of nice to be in there. So then we get 8 times 9 is 72. K cubed times k, this is k to the 1. When multiplying powers of the same base, you add the exponents. So this would be k to the 4. And then again, y to the 1 times y cubed, 1 plus 3 is 4. And that's my final answer. And I can't go any further. I'm not solving. I've just simplified by multiplying. So now what I'd love you to do is pause the video and give this one a go. And again, I wouldn't show all the steps I showed here. I'm just going to go 2 times the negative 5 is negative 10. X to the 6 times x to the 2 would be x to the 8 because you're adding the exponents. And y to the 3 times y to the 1 would give you y to the 4. And then once you have that basic skill kind of going, then we're going to expand it. So instead of multiplying monomials by monomials, so one term by one term, we're going to do monomials by trinomials, or monomials times binomials, or binomials times binomials, and so on. So for this first one, this one we just called this multiply. This one we're going to call this a distribution. This is negative 9 times these three terms. So what I like to do is actually draw the rainbow and show that I'm going to distribute this negative 9 through the bracket. What does that mean? Well, it means I'm going to multiply the negative 9 by the 5m squared. I'm going to multiply by the negative 9 by the negative 7m. I'm going to multiply the negative 9 by the negative 3, which would give me negative 9 times 5 would be negative 45m squared. Negative 9 times negative 7 is positive 63, and then there's still that m that we need to multiply by. And then negative 9 times negative 3 is positive 27. And that would be the simplified answer. Pause the video, give this one a go. So this one we're doing a monomial by a binomial, so I'm distributing between two terms. And again, you don't need this first step, but I do kind of like it when you're starting. We're going to multiply the 2xy by the 3x squared, and we're going to multiply the 2xy, and you'll notice I put a plus sign here because this is a positive 2xy, by the negative 5y cubed. And then I multiply. So some people do it as they go. Sometimes it's nice when there's lots of variables to write it out. So 2 times 3 is 6. X times x squared is x cubed. It doesn't have a y, so it just keep the y that's multiplying. Then we have plus 2 times negative 5 is negative 10. X times, well, there's no x term in there, so just the x. And then y times y cubed is y to the 4. Then I've asked these next two questions on purpose. What I want you to notice is the difference between the two of them. I've got 3x minus 2 times x minus 6, and I have 3x minus 2 times x minus 6. What's the difference? Well, the difference is brackets. This one doesn't have brackets and this one does. So what does that mean? Well, it means in this one that the only thing multiplying is the negative 2. It's the only thing touching the bracket. So in this one, I'm going to distribute negative 2 only. Whereas in this one, it's this whole bracket just multiplying with this whole second bracket. So I like to call these big rainbows or chins and eyebrows. These are the eyebrows. I have to multiply the 3x by the x and the 3x by the negative 6. So I've distributed the 3x, but then I also have to distribute the negative 2. So it's going to be negative 2 times the x and negative 2 times the negative 6. So the biggest difference here is that here only the negative 2 is multiplying through, and in this one everything in the first bracket has to be multiplied by everything in the second bracket. So let's do this first one. We've got the 3x, and then we're going to distribute the minus 2. So minus 2 times x is minus 2x, and minus 2 times minus 6 is plus 12. And then you always look to see if you can collect like terms. With this one I can. 3x minus 2x is x plus 12, and then that's fully simplified. This one I'm going to multiply through. I get 3x times x is 3x squared. 3x times negative 6 is negative 18x. Negative 2 times x is negative 2x, and negative 2 times negative 6 is positive 12. Now with this one, you'll notice that when you multiply binomials together, when you have this like x and then a number, x and then a number, what will always happen is that these two middle terms will always be like terms. So I will end up with a 3x squared out front. I'll get negative 18x minus 2x is negative 20x, and then plus 12. Now, when you're learning to multiply two binomials together, which is what we just did here, so all of these first three was distributing a monomial. This one was a binomial times a binomial. Some people ask me like, well, I remember this thing from high school called FOIL. What's FOIL? So when you're multiplying binomials, there's a process of doing it called FOIL. You can totally ignore this. What you did was FOIL. We did the first times the first, the outer times the outer, the inner times the inner, and the last times the last. That is FOIL. It just refers to the order with which you multiply, but the idea behind FOIL is that it's supposed to kind of get you to multiply quicker. In other words, I love writing this step, but it's not essential. Some people might look at two binomials and be like, okay, so when I multiply these together, I'm going to do the first. So 3x times 2x gives me 6x squared. That's going to be the first part of my answer. So 6x squared. Then they know that you're going to have your inners and your outers. So you've got your inners and your outers. Oh, where's my outers? Oh, here we go. Sorry, I'm like, where are the arrows going? So my inners and my outers. So they'd look at this and be like, okay, negative 8x and 9x makes just an x. So my middle term is going to be an x, and then my last term is going to be my outers. So negative 4 times positive 3 is negative 12. So I didn't have to write down any work. Now, is that a good thing? Or is it a bad thing? Will you make more mistakes when you do it in your head? Or will you make less mistakes when you write it out? So I just show this, and the reason that I agree to show it in my own head is because in chapter 5 we're going to be factoring, which is where we take something that looks like 3x squared minus 20x plus 12 and turn it into 3x minus 2 times x minus 6. And it's really good if you can do a quick check. Does my first times my first give me the first? Do my outers and my inners give me the middle? And does my last times my last give me my outer or my last number? And so it can just be a great thing. So what I'm going to say to you now is that we're going to do these two questions. It's a binomial times a binomial. I don't care whether you do them in your head, thinking first and then outer inner together and then last, or whether you literally do a giant distribution. 4x times 3x is 12x squared. 4x times negative 1 is negative 4. Negative 3 times 3 is negative 9x. Oh, I forgot my x on there, sorry. And then negative 3 times negative 1 is positive 3. You can write that out, or you can think. First times first, 4x times 3x is 12x squared. My outers would give me negative 4x. My inners would give me negative 9x. Together, that gives me negative 13x, right? Are you doing it in your head, or have you written down this step? Doesn't matter to me. Plus 3. So pause the video. I want you to try this one. Now I did do an extension with this one too, where I threw in two variables, but just know that your middle, maybe we should just do it together. Your middle term is going to be a k and an m. So if we look at this, let's do the first times the first. So 2k times 3k is 6k squared. And if you still like that first step too, I forgot that we were doing it. You know, this step up here where we were showing the actual multiplication before we did multiplying, feel free to throw that in. You know, throw as many, more steps is better. Less steps can be bad. Okay, but anyway, 2k times 3k is 6k squared. And then we've got 2k times 2m, which gives me positive 4 km. Now I'm going to write it as km because I always write alphabetically. So even when I go to the next one, which is negative 5m times 3k, I'm going to go negative 15. And even though it looks like mk, I'm going to write it as km. Just because if you go alphabetical, it's easier to see the like terms. And then negative 5 times positive 2 is negative 10, and m times m is m squared. And then your two middle terms will always be like terms. You get 6k squared minus 11km minus 10m squared. Now, if you did that in one step because you were thinking FOIL, great. I don't know if I ever really, when I'm being really lazy, I do, but to be honest with you, most of the time I just write out the two middle terms and then I collect them together. One thing I want you to notice, though, is that we did 3 questions where we multiplied a binomial by a binomial. So here, here, and here. And what I want you to notice is that whenever two binomials are multiplied together, the product is always a trinomial. It's always 3 terms. There'll be the first term, and then the outers and the inners combined together, and the last term. All right, moving on, we're going to stick with this idea of multiplying binomials, but we're going to add another layer to it. So sometimes instead of multiplying a polynomial with a polynomial, we can do a polynomial with a polynomial with a polynomial. In other words, this is a monomial times a binomial times a binomial. And people are always like, well, what do I do? And they don't write this, but a lot of people go, okay, I'm going to multiply the 3x through, and then I'm going to multiply the 3x through there. And I'm like, really? Are you? Should you? And how I always ask you is, if I asked you to do, 2 times 3 times 4, do you have to do 2 times 3 and 2 times 4? Or do you find the product of two numbers, like 2 times 3 is 6, and then take that product and multiply it by the 4 and get 24? Or multiply the 3 and the 4 together to get 2 times 12 and get 24? Right? You don't have to distribute through twice because when you multiply two of them together, they've already multiplied and you are together then multiplying by the third term. So when there's like something that looks like this, like that giant distribution idea with 3 different polynomials, do not multiply through with the monomial by everything. Okay, here's what I would do. Now it's your choice. You could distribute the 3x through and then take that binomial and multiply it by the other one, but I always tend to do the binomials first. And the reason is, do the binomials when they're smaller numbers. So for example, where this one I'm going to keep the 3x out here, but I'm going to multiply x plus 3 by x minus 2. To do that, I'm going to keep it in a bracket because I still need to multiply. I'm going to go x times x is x squared. X times negative 2 is negative 2x. 3 times x is 3x. And then 3 times negative 2 is negative 6. Then before I distribute the 3x, I'm going to collect like terms. I don't have to, but I feel like it makes my life easier. Negative 2x plus 3x is positive x. And then I have the negative 6. Now I'll distribute the 3x through. So I've got 3x times x is 3x cubed. 3x times, I think I said that right, 3x times x squared is 3x cubed, and then 3x times x is 3x squared, and 3x times negative 6 is negative 18x, and that's a great way to do it. Now I just want to prove to you, you don't ever have to look at this again, but if I'd done it the other way, if I had done 3x times x plus 3 times x minus 2, and I had done the 3x through first, I would get 3x squared, so I'm just going through this first bracket, plus 9x, and then that would still be in a bracket and it would multiply by x minus 2, and then I'd have to do this distribution with like bigger numbers. So I've got 3x squared times x is 3x cubed, 3x squared times negative 2 is negative 6x squared, 9x times x is plus 9x squared, and then 9x times negative 2 is negative 18x. And then I would collect like terms and get 3x cubed plus 3x squared minus 18x. So I got the same answer doing it that way, but it didn't feel as nice. So my recommendation is do the binomials first and then distribute your monomial through. So now pause the video and give this one a go. I didn't like that you could see it through there. Okay. So for this one, I'm going to do negative x times. Now, personally, with ones that look like this, I would probably do the FOIL thing. I'm like, first times first is x squared. And then 5x minus 7x gives me negative 2x. And negative 7 times 5 is negative 35. So if you're at that point, do it. Otherwise, x times x is x squared. X times 5x is negative 7 times x, and negative 7 times 5, and then collect like terms. But now I'm going to distribute that negative x through. I get negative x cubed plus 2x squared. So I think of this as negative 1 times negative 2 gives me positive 2, and then x times x gives me x squared. And then again, negative 1 times negative 35 is positive 35, and then an x. And that is fully done. The last thing we're going to do in this video, it's ending up longer than I like, but the last thing we're going to do in this video is what about when there's really big ones? So what if we're doing a binomial by a four-term polynomial, or even a binomial times a trinomial? So I want to show you this alternative method. It's called multiplying vertically. There's another one in the textbook too called multiplying using the rectangular method, but every time I've taught it, I've never seen someone use it, so I've actually cut it out of the notes. But I don't actually use the vertical method either, but I take something from it that I use. So you'll notice this question is the exact same one here. So I'm going to do it two different ways, and you're going to decide which one you like the best. So the vertical method is thinking of this like a long multiplication. So I'm going to do negative 5 times negative 3 to get 15. I'm going to do negative 5 times 2a to get negative 10a. I'm going to do negative 5 times negative 6 to give me 30a squared, and negative 5 times 5a cubed to give me negative 25a cubed. Then I'm going to multiply the 2a through. I've got 2a times negative 3 to get negative 6a. And what I do is I don't write it underneath the 15. I write it underneath its matching term. So 2a times negative 3 is negative 6a. 2a times 2a is 4a squared, positive 4a squared. And 2a times 6a squared is negative 12a cubed. Ooh, I'm going to have to squeeze. And then 2a times 5a cubed would be 10a to the 4. Now, I don't really like this method in this part, but what I really love is the addition. Notice how all my terms are lined up as like terms, and I can just add down. I'm like, okay, 15, negative 6a, I got to put my plus sign in there. Negative 16a, I don't know what I just said there. 30a squared plus 4a squared is 34a squared plus. Negative 25a cubed plus negative 12a cubed gives me negative 37a cubed. And lastly, 10a to the 4. So what I like to do is kind of think about this vertical method, but I don't actually like it vertically. What I liked about the vertical method is that my addition came out really nice. If you think about if we had done this longhand, so if I had started this one and I took it and I wrote this out, I'd have 1, 2, 3, 4, 5, 6, 7, 8 terms all strung out in a line, and it ends up huge. So what I do is I actually distribute, but I keep this part of the vertical method, and I'll show you what I mean. So I'm going to do 2a times 5a cubed, and I'm going to get 10a to the 4. And right away I'm like, oh, this feels better. I have to kind of force myself to try this vertical method. But maybe for some of you, you're like, ooh, I like that. Okay, for me, I like this because it's what I'm used to. So then I'm going to distribute the 2a by the negative 6a squared, and I get negative 12a cubed. Then I'm going to do the 2a times the 2a to get plus 4a squared. Then I'm going to do the 2a by the negative 3 to get negative 6a. I gotta stop hitting that thing. Then I'm going to distribute my negative 5. But instead of keeping on writing out, I'm going to steal this from the vertical method. And I'm going to say negative 5 times 5a cubed is negative 25a cubed, and I'm going to write it underneath. Then I'm going to do negative 5 times negative 6 is positive 30, and then the a squared. And then I'm going to do negative 5 times 2a is negative 10a. And negative 5 times negative 3 is positive 15. Then I can add vertically. So I don't really like the multiplication vertical, but I love the addition vertically. And again, I get 10a to the 4 minus 37, 37a cubed plus, that was a 30, 34a squared minus 16a plus 15. And it just feels better. Trust me, trying to write 8 terms out takes forever, but if you line them up and then you're like crossing out and color coding, I love a combination of distribution with a vertical method. So what I want you to do now, and then this is the end of the video, is just try this one. And I made it smaller. So you can set it up as a vertical method right from scratch, or you can do as a distribution with the vertical addition, or ignore me altogether and write it out in one big line. Or alternatively, go to the textbook, read about the rectangular method. So I'm going to do this as a distribution. M times m squared is m cubed. M times negative 2m is negative 2m squared. M times negative 3 is negative 3m. Then I'm going to go for my next one, negative 5m squared. I'm going to write it underneath my m squared term. Negative 5 times negative 2 is positive 10m. And then negative 5 times negative 3 is plus 15. Draw your line, add down. This will give me m cubed minus 7m squared plus 7m plus 15. And it wasn't such a big one, but even if you just add on that trinomial instead of a binomial, I love this vertical method. So again, I don't use this until they come up with multi-term polynomials bigger than 2, but I do find this incredibly handy. But you can ignore me, you can write it in a line, you can look up the rectangular method, and you can kind of create your own. Hope you feel good.